There's a specific kind of AI production failure that looks completely fine from the outside. Your agent runs, it completes, it returns results. Your error rate is 0, your latency is normal, and your on-call didn't get paged. Everything is green. And then your cloud billing alert fires on Friday. That's the failure mode I want to talk about today, and specifically about how standard observability tools, the APM stacks, the trace backends, the alerting systems that work perfectly for HTTP services and databases, are blind to it. We had a multi-step agent. It researched a topic, summarized findings, then filed a Jira ticket. Took about 20 seconds per run. Worked great in staging. We shipped it. A week later, our billing alert fired. $4,200 for the week on this one agent. Expected, $80. When we dug in, the cause was a prompt change someone had made innocently. That caused the agent to include the full conversation history in every tool call. By iteration 8, the agent was sending 11,840 prompt tokens instead of 400. At GPT-4o pricing, that's a significant difference per call, multiplied across hundreds of runs per day. No exception was raised. The agent was completing correctly. Our APM stack Datadog in this case had a span for every LLM call. Duration, fine. HTTP status, 200. That's all it captured. Token counts, prompt sizes, costs, none of that appears in a standard HTTP trace. And this is the core problem. LLM calls aren't like database queries or HTTP endpoints. The failure modes are different. A database query either succeeds or throws an exception. An LLM call can succeed structurally, return a valid JSON response, HTTP 200, no exception, while failing semantically. The output is truncated. The tokens are 30 times what they should be. The wrong model ran because your alias resolved differently. Semantic failures in LLM systems are invisible unless you instrument specifically for them. OpenTelemetry published official semantic conventions for GenAI operations, stable as of OTel 1.26. Standard attribute names that work with any OTel-compatible backend. The key attributes: GenAI usage prompt tokens and completion tokens. GenAI usage total cost USD, which you compute from the token counts and a pricing table. GenAI finish reason, this is the one that catches truncation. And GenAI response model, which is the actual model that ran, not what you requested. That last one is subtler than it sounds. When you request GPT-4o, the API resolves that alias to a specific model version at runtime. The resolved version has a specific price and specific behavior. Logging the response model catches when aliases change under you. The wrapper is about 50 lines of Python. A function called traced_LLM_call that wraps any OpenAI-compatible API call. It starts an OTel span, sets the request attributes, calls the API, reads the response, sets the usage attributes, checks finish reason, and closes the span. The finish reason check is where you catch the silent failure class. If finish reason is length, the model hit the max tokens limit. Output is truncated. The response was 200, but you should treat this as an error. The wrapper marks the span with status code error and adds an event recording how many tokens were used versus the limit. That event now shows up in your error rate. For multi-step agents, you want a parent span for the whole run and child spans for each LLM call and tool invocation. OTel's context propagation handles this automatically. Any span you start inside an existing span context is a child. So you start an agent.run span, and inside the agent loop, every call to traced_LLM_call starts a child span automatically. When the agent finishes, you set the total cost and iteration count on the parent span. In your trace backend, you now see the full agent run as one trace, with each step as a child. You can see at a glance how token counts changed across iterations. In our case, we'd have seen prompt tokens rising from 400 to 11,840 across 8 iterations, which would have fired the anomaly alert we added afterward. 4 alert rules we added after the incident. Prompt token spike. Alert if the 95th percentile prompt tokens for any task type is more than 1.5 times the 7-day baseline. Window of 15 minutes. This catches context accumulation and prompt regressions before they run for a week. Truncation rate. Alert if more than 2% of finish reasons are length. Silent truncation at that rate means corrupted outputs reaching your users. Cost per task. Some costs grouped by a task name attribute you set on every call. Alert if any task type exceeds your expected per call ceiling. We set it at 5 cents per call. Model mismatch. Log whenever response model doesn't match request model. Aliases resolve to versions. Versions change. The killer feature I didn't expect. Once you tag every LLM call with a task name attribute, you can query your trace backend to break down costs by product feature. We found that 80% of tickets going through expensive full analysis didn't need it, a routing logic bug. Fixing it saved $192 per day. You don't find that by looking at overall API spend. You find it by breaking costs down to the task level. The instrumentation is 50 lines. The OTel backend, Grafana Tempo, Honeycomb, Datadog, you probably already have one of these for your other services. The semantic conventions are standardized and stable. There's no good reason to be flying blind on LLM token costs and finish reasons in production. The tooling exists. It just needs to be wired up. Full code is in blog 269. Link in the description. If this was useful, subscribe for the next one covering tool call schema design for agents, which is a topic most teams get wrong in ways that are very hard to debug.